Welcome back. Sometimes physics isn't just about equations. It's a detective story. And today, we've got a great one. It's about a beautiful theory that was almost dead on arrival, a hunt for a fatal flaw hidden deep in the math, and a ridiculously clever trick that not only saved the day, but also told us something absolutely staggering about our universe.
So let's start with the central mystery. What if you came up with the most elegant set of rules to describe a simple, vibrating string, but when you worked through the math, it started predicting things that were literally impossible, things that would break reality itself? What would you do? Because that's the exact crisis early string theorists found themselves in.
Okay, so let's set the scene. We're at the very beginning of what could be a revolutionary new theory, string theory. But right out of the gate, there's a huge problem. There's a ghost in the machine. Or, well, a ghost in the string.
So what in the world is a ghost in this context? Well, in physics, everything boils down to probability, right? The chance of something happening. But what does a negative probability even mean? A minus 20% chance of an electron being here? It's pure nonsense. It's a flashing red light telling you your theory is fundamentally broken and can't describe the real world.
And that's exactly what was happening. The moment physicists tried to apply the laws of quantum mechanics to a vibrating string, these ghost states with negative probabilities started popping up all over their calculations. The whole thing looked like it was doomed. This beautiful, elegant idea was leading to a physical impossibility.
But physicists don't give up that easily. They figured the problem wasn't with the string itself, but maybe with how they were looking at it. The next phase of the investigation meant they had to get clever and start slicing up spacetime in a whole new way. And the key tool for this investigation is something called light cone coordinates. Now, instead of thinking about time and space as totally separate things, you kind of mush them together. It's a really weird, counterintuitive way to map things out, but as you'll see, it's incredibly powerful for tackling a problem like this one.
Okay, I know this looks a little intense, but the main idea is actually pretty simple. Don't worry about the symbols for a sec. Just see how that X with a plus sign, what we call light cone time, is made by literally adding time and space together. Physicists found that if you keep them separate, you get ghosts. But if you mix them up into this new kind of coordinate, you get a whole new perspective that might just crack the case.
And here's what that new perspective looks like. When a string moves through time, it traces out a surface, right? We call that a world sheet. What you're looking at here is that surface. Those light cone coordinates are like a new custom-made grid you draw right on top of it. It's a tool that lets us track all the string's little wiggles in a much smarter way.
And now we get to the breakthrough. Armed with this new way of seeing things, our physicist detectives are about to make their move. This is the moment they set the trap that's going to catch the ghost. It's all about making a choice, what they call choosing the light cone gauge.
So here's the fix. The theory itself has a bunch of wiggle room, different ways to describe the exact same physics. A gauge choice is basically just picking one very convenient way to look at it all, and the genius move was to force the string's motion in our new light cone time to be as simple as possible, to just tick along like a steady, predictable clock. And this is that choice, written down as an equation. Again, don't let it scare you. The idea is so elegant. All we're doing is declaring that one of the string's many motions, this x plus, is now going to be super simple and predictable. It's directly tied to that tau variable, which you can just think of as the tick-tock of a clock on the string itself. We've simplified one piece of the puzzle on purpose just to see how it affects everything else. And this is where it all pays off. By making that one simple choice, we basically force the theory to confess. We can finally see what the string really is. We can separate its true physical motions from the parts that were just mathematical noise all along. Now look at this. This is the aha moment. Remember those two light cone coordinates, x plus and x minus? We already tamed x plus and turned it into a clock. Well, the incredible result is that the other coordinate, the troublesome x minus, is no longer free to do whatever it wants. Its behavior is now completely locked in, totally determined by the simple, physical wiggles of the string in the other directions. The ghost hasn't vanished. It's been put in chains, tied to reality.
So what does this all mean? It means that after all this complicated maneuvering, the true nature of the string is incredibly simple. Its physical properties, its energy, what kind of particle it is, all come from these simple wiggles, the transverse oscillators. It's just like a guitar string. The only thing that really matters is how it vibrates up and down and side to side.
And just like that, the case is closed. We've found the source of the trouble. It was just mathematical clutter. And we've isolated the real physical behavior of the string. Now and only now can we safely bring in the rules of quantum mechanics and build a real theory.
So, let's just recap this amazing procedure. Step 1, you choose your special viewpoint, the light cone gauge. Step 2, that choice automatically locks down all the unphysical, ghost-like motions. Step 3, you're left with only the real physical stuff, those simple transverse wiggles. And finally, step 4, you build your quantum theory using only those real parts. No ghosts allowed.
And this quote just says it all. It's the victory lap. The space of all possible quantum states is now positive definite. That's the fancy physics way of saying the best thing you can possibly hear. We're safe. We don't have to worry about ghosts anymore. Every single state in our theory now has a nice, sensible, positive probability. We did it.
But, like in any good detective story, there's one final twist. This whole beautiful solution, this perfect ghost-busting procedure, it only works if one very, very strange condition is met. And that condition is a number, 26.
And that's where we'll leave it, with this mind-bending question. In order to kill the ghosts and make the whole theory work, string theory demands that we live in a universe with 26 space-time dimensions. We solved one paradox only to uncover an even deeper mystery about the fabric of our cosmos. And why that magic number is 26? Well, that's a whole other detective story for another time.